Hello everyone, thank you to the organizer of this event. So the first talk is about identifiability and generalisability from multiple experts in inverse reinforcement learning, and it's a work with Paul, Norman, Boris, and Wolfgang. Can I go on? Okay. So let's start introducing our setting. We have multiple experts that I denote as these training environments, where the goal is the same. I want to go to the orange dot, but the transition dynamic of the environment are different because the wall is in a different position. And I would like to learn a reward that when I change again the position of the wall, I have only one hole in the test environment, I can still learn by reinforcement learning the optimal trajectory that will go through the wall. This is quite different from the standard inverse reinforcement learning, where we have only one environment and we want to find a reward that will allow to recover the optimal behavior in this environment. But there are infinitely many solutions to this. So a sufficient condition to achieve our goal is to identify the reward up to a constant, and we find a sufficient and necessary condition expressed by the rank of this matrix such that recovering the reward up to a constant is possible. And intuitively, this condition is saying that the two environments should be different enough to provide to the learner enough knowledge. So we started this project for having some finance application where basically you observe a trader in the market and you would like to understand how he would behave under different market conditions. And in finance, you often have an exogenous variable that they evolve without dependence on how the agent take action. In this case, identifiability is not possible, so our condition is too strong. And we have now another theorem for generalizing. In this case, it depends also on T3, that is the test environment. So this condition is saying that if the two environment at training time, T1 and T2, provide enough information on the test environment T3, then we can generalize even if we don't identify the reward. Then we verify our claim with some experiment. These are the identifiability case, where the first three plots, you cannot see the difference between the true one and the one that is recovered. While in the generalizability case, you see in the middle plot, I have the state on the vertical axis, the action on the other axis. I have two rewards that are really different, but then on the rightmost plot, the difference is just zero everywhere for the policy that I recover from this reward.